Hey there. In this video, we're going to discuss the one last major surprise that the Wiggle has for us. I'm going to go get myself an image of the thing and place it into Photoshop. Alright, this is the Wiggle for, I believe, 32 within times 3 plus 1 space. I'm going to take that image, duplicate it, and make the opacity so it's transparent. Alright, so if we take this Wiggle, you see here that it's some kind of strange semi-sinusoidal shape. That's why I call it the Wiggle after all. It repeats, but it doesn't quite repeat nicely. So let me show you what I mean by that. If you take it and you drag it over itself to maybe like here, you can see that it's semi-periodic. But it wasn't until a good while later into my research on this thing that I noticed one day that if you take it and you drag it further, that it doesn't line up with the second wave. I mean, it's close, it's real close, but it doesn't quite line up. Doesn't quite line up again. Doesn't quite line up again. But then if you push it far enough, it's 5 notches over. The two images directly overlap each other, like perfectly. I'm going to, just to show you how clear this is, I'm going to turn this one on and off. It overlaps, it's wildly periodic. The time frame upon which that happens, because this is a logarithmic x-axis, is in multiples of 4 over 3. So if you're at a particular value of n, and you multiply that n value by 4 over 3, and round to the nearest integer, you end up getting a percent membership that's almost spot on for where you were before. Mind you, if you look far enough, we're studying out here, we're well out to the hundreds of millions, near a billion. When you're pretty far out studying one of these Wiggles and it's actually coalesced, it becomes very periodic.